Hi there. Welcome to this video on dimension reduction use cases. We live in a world of big data which gets bigger day by day. And one of the ways to make sense of this data is to make it smaller. And this is where dimension reduction techniques can help. So in this video, I'll be explaining the dimension reduction with the use cases shown on the screen. I'll be explaining them with examples and visuals, and there's no complex programming screens. So whatever your profession, you can just sit back, relax and enjoy the video. So friends, let's get started. But before that, do not forget to subscribe to the channel, like and comment on the video. Avengers Assemble. In this section, we will use a dataset on Marvel characters. This dataset has got information on Marvel characters such as the name, the gender, the alignment, and the superpower capabilities such as the agility, durability, magic, telekinesis, etc. etc. You'll be surprised to know the different types of superpowers which these characters can have, such as dimensional awareness, energy absorption, telepathy, and this dataset has got 175 types of superpowers. Now let us say you have to make a data storytelling where you need to start speaking about a character and then another one and then another one. This will require converting a table with 175 dimensions into one-dimensional data so that we can represent all the characters on a single 1D line. And this is achieved using dimensionality reduction algorithms. Here is the result of the dimension reduction algorithm. Each dot corresponds to a Marvel character. Now let us see what are these characters here starting from the left. We see here that the leftmost dot corresponds to the character Rocket Raccoon. You can also see a radar chart which indicates the superpowers. And we see that the Rocket Raccoon has got superpower which are animal-oriented powers as well as is a weapons master. Now let us move to the next character, which is Black Panther. We observe that the superpowers are from animal-oriented powers. Moving further, we see Spider-Man. Once again, we observe that the superpower is based on animal-oriented powers. So it is becoming very clear that the characters on the left-hand side of this line have superpower which are based on animal-oriented powers. Now let us move to the middle of the line and let us look into this dot, and this corresponds to Scarlet Witch. And we observe that she has got superpower which are based on teleportation and magic. Moving further, we see Doctor Strange, whose superpowers are also based on teleportation and magic. So we see that the middle part of our line corresponds to the characters whose superpowers are based on teleportation and magic. Now let us move to the end of the line, and we see that this dot corresponds to Captain Marvel. And we observe that she has got multiple superpowers such as teleportation, magic, energy manipulation and omnilinguism. For those who are curious, omnilinguism means the ability to understand and utilize verbal or non-verbal communications without any prior knowledge of the language. Now that's a great superpower to have. Let us now move further, and we see Thanos, who also has got multiple superpowers. So we observe that the end of the line corresponds to the characters who are having multiple superpowers. So if we have to tell a data story, we can start with the characters having animal-oriented powers, and then we speak about the characters with teleportation and magic, and then we can end with the characters who have multiple superpowers. So as you can see, that dimensional reduction is a great way to transform multiple dimensions into a single dimension, and this is really an awesome data science superpower. Latent means something existing but hidden. Dimension reduction techniques can help us to discover the latent factors in the data. I will illustrate this using a dataset on personality traits. The dataset is collected by interviewing a group of people and collecting information on various personality traits. The dataset has got about 30 plus personality traits, and we will use dimension reduction to discover 3 hidden or latent factors. These 3 latent factors will in fact represent 3 different personality types. So here is the result of the latent factor analysis shown as a tree diagram. On the right hand side, we see the most important personality traits in this data set. This corresponds to the column in the data. All the personality traits are grouped under 3 groups, which correspond to the latent factors. We observe that the latent factor 0 corresponds to a person who makes people feel at ease, knows how to captivate people, and can make friends easily. So this would correspond to a personality type who is friendly and a charming person. Now we do not have any data column on friendly and charming in our data set, but the algorithm is able to find this latent factor. The second latent factor corresponds to a person who gets angry and irritated easily and has got frequent mood swings. So this corresponds to an annoying personality. And the third personality type corresponds to a perfectionist who is exacting and likes to do things as per plan. So all these personality types do not exist as columns in the data, but the algorithm is able to find these personality types as latent factors. Let me illustrate this section with the data on telco customer dataset. This dataset has got customer information such as the demographics, what kind of services the customer has, as well as the billing information. There are about 40 plus columns in the data. As humans, we can see things in 2D or 3D. As dimension reduction can help us to go from a high dimensional space to a low dimensional space such as 2D without losing the essence of the data, it is a great tool to help us visualize the structure of the data. Here is the result of dimension reduction. We have just reduced 40 plus dimensions to just 2 dimensions. As a bonus, we also see a cluster formation. And this signifies that the dimension reduction has been done without losing the essence of the data. We have a blue cluster and a green cluster. Let us now analyze what these clusters mean. Here is the radar plot which gives the information on what these clusters mean. We see the blue cluster over here, which corresponds to high paying customers and those with multiple services. While the green cluster over here is the low paying customers with limited services. Now this insight would have been difficult to obtain by just looking at 40 plus columns, but the dimension reduction has helped us to make sense out of data by putting it in a 2D form. Thank you for watching. Do not forget to subscribe to the channel, like and comment on the video.